Hello and welcome to this InflectraCON 2023 virtual bonus session. InflectraCON will be held from April 19th through the 21st in Washington, D.C. on the campus of Gallaudet University. We are looking forward to 3 days of customer training, partner meetings, industry sessions, networking, and more. Check us out at www.inflectracon.com. In this session, we hear from John Hagar, CEO of Grand Software Testing. Let's get started with this virtual bonus session entitled IoT Software Systems Testing and Security Assessments.
Good day. This is John Hagar. I'm going to do a session for InflectraCON. The session is on IoT software system testing and security assessments, everything, everywhere, all at once. A little bit on my background. I've been in software for about 44 years. I've written a couple of books. This session is based upon the most recent book, which is IoT System Testing. And obviously the book has a lot more than we'll be able to cover in just 45, 50 odd minutes here in the session. And let's go ahead and move forward. So on the introduction, the Internet of Things, which is what this session is about, is one of the hot growth areas in tech. It's presenting some challenges. The big problem that I'm going to talk about today is system and security testing while still being agile. And I'll talk about both what I mean by system testing and security testing as we go through this. My experience working with some companies is that a lot of managers and stakeholders in IoT wish that they could just test the device in a standalone mode. But a lot of IoT devices are going to be used as part of a system, some very large systems. And if you don't consider that at some point in the test activities, strange problems can be missed. One of the most severe ones that I'm always worried about nowadays is the bullet there on security. Security has become to the forefront. We didn't used to worry about it in the embedded days that I came out of, but now with the Internet of Things being connected to the internet, security is a big problem space that we have seen where IoT devices have actually been used to support hacking. And trust me, you don't want those kinds of things. So I'm going to give you some ideas and maybe a little bit of thoughts on skills that would benefit IoT system testing and security assessment. I'm going to advocate quite a bit looking beyond just the individual device itself. We certainly have to test the device, but we're connected to the internet and a other set of systems and things. I will also have some information on cybersecurity, white hat, and I don't want to see this used for the black hat hacking kinds of things, but a good white hat hacker has to think and know some of the tools of the black hat guys. So we're going to cover that a little bit. I also want to talk on system and security testing, verification, and validation, the system level of things. So you'll see slides on V&V and IV&V. And certainly the old manual testing that we're all familiar with will be important at various points in the IoT testing scheme of things. But we find IoT is going to move quickly into things like test automation, V&V security testing, and I'll cover some things on AI, artificial intelligence, and data analytics. I'd like to advocate for people learning this thing that practitioners can master these new skills. It takes a fair amount of time and effort, but it could be good for your careers to do that. So, when we say IoT will be everywhere in everything, we are seeing devices with electronics become part of IoT. Interestingly, though, some non-electronic things are starting to have little sensors and chips and things put them. They become part of IoT. So it's a growth area, everything, everywhere, all at once. It's all going to need to be tested. And we see a little mind map here, classification of things. You have the consumer IoT, which a lot of people are familiar with, of home and personal and use by children and travel and entertainment and robotics on the consumer side, the little vacuum cleaners running around your house. On the industrial side there on the right, you have IIoT, Internet Industrial aspects. Here we have the smart factories and smart transportation, cars, smart construction, retail, and huge robotic systems, not just your vacuum cleaner running around your house. And in the middle there, you have things like medical tracking, personal transport, maybe your smart car, safety and security, and robotics again. So how many of these things are we talking about? Well, kind of there in the middle, we see millions, billions, maybe even someday trillions of things. And we'll hit a few times. I live in Colorado in the mountains. We've had huge snowfalls. I've been out plowing every day for the last 10 days. And the picture there at the bottom is actually a smart snow plow that I own and run. So a little bit of setting the stage here, agile IoT system testing. What do I mean when I say verification? It's assessing that the system meets its requirements, design, and specifications. That's the thing most testers are familiar with on just running tests to show the requirements are met and the system doesn't have any obvious bugs. I like to expand into the validation side of things. And this is where we look at the system to assure that the stakeholder needs are met, oftentimes beyond the published formal specification. A little bit harder to do this, but with some good understanding and skills that we'll cover later, validation can be done. Testing of just the standalone devices, I've already kind of said, is necessary, but it's not sufficient by itself. Somebody has to look at it when you plug it into the internet, and we're going to talk about that. The reason for this, hopefully, is obvious, but if the device doesn't work, users will stop using it. And we all want to sell things, right? But worse, what we've seen now in the days of social media, people will publicly complain about something, which can be the kiss of death for a piece of hardware and software. So I like to recommend projects and people using IoT, think about verification, validation, the V&V, and maybe in some cases, even independent V&V. Independent V&V has a long history in things like working with larger organizations, governments, the military, and IoT is going to probably have to have some of that, maybe not everywhere, but in critical areas. So this is all going to be driven out of the changes that IoT will bring to society and our system of economics. We saw it going back to when the PCs first arrived, and then the web arrived, and then the social media arrived. I've lived through all that, and it's always transformative. And you end up having to think about everything kind of everywhere all at once, kind of like the movie. Hopefully not quite as crazy that movie was, but it was an interesting movie. I'm going to advocate quite a bit that the test environment needs to be set up to include the hardware, because it's a thing, the software, because it's hooked to the internet, the testing, the operations, and the system elements. Now, does every IoT device have to do that? No. But say you're working with something that's controlling stoplights in a smart city. That's probably going to need a little more effort where people aren't going to be happy if all the lights turn red and they can't get home on time during rush hour. So what does this look like? What's the everywhere? Well, we start over here in this picture on the left side there, where you kind of have your house. And it's filled or going to be filled with some IoT devices, maybe some cameras, some speakers, information systems. But once you're there in the house, it's going to be connected to an edge device. Could be a PC, could be a modem, could be a cell phone. I use smart modems and cell phones on a lot of my connections. And then there's a connection in the picture over there to the right side in the cloud. The data goes into the cloud and is stored there. This is a system software architecture. And if you just test inside of the left side of the box there inside of the house, that's a good idea, but as I said earlier, it's not sufficient. At some point, you're going to have to link to the edge and to the cloud. Along with that comes security. Security will be everywhere in Internet of Things. I've already mentioned we've seen people hacking baby cameras in the house, a very big security threat there. We've seen IoT devices used in what's known as a denial of service attacks. We'll talk about that a little bit more in a few slides. So these things have already happened. This is stuff you've got to be aware of going today. So some examples of this. I mentioned I live in Colorado. I'll use the term semi-smart house. It's been getting smarter over the last years, but one of the things we do is we have solar panels. You see there in the picture on the upper side. They are in fact smart solar panels. They're connected into the house and talk to an internet connection, and we can track what's going on month by month and how much energy we generate and all those kinds of things. Well, we live, as you can see in the picture, up in the mountains, very different kind of place from what the vendor, and I have talked to the vendor, what they initially thought was going to be done. We had some unusual configurations. Now, both my wife and myself are techies, so we were able to work around all that stuff and solve it and keep the system up and working. But not everybody's a techie. And maybe IoT companies, when they're doing these things, have to realize that the typical user is probably not as smart as somebody like my wife and myself. So, whose job is that? Our answer was, well, it was ours, but I think in the future, if you're filling that in, it may be the test people and the people developing these systems have to think about these integration issues. Next one picture down there, I mentioned I have a snowplow. And some of you that are skiers probably recognize that actually as a snowcat. We get a lot of snow up in the mountains of Colorado, especially this year. We've just been going through all the storms that maybe a lot of you are familiar with here at the end of February. And the piece of equipment I have has a little computer, a little processor in it. And when I was first learning to use it, I was out plowing, and all of a sudden the whole thing stopped. I checked on my phone, and the codes didn't mean anything. So my question to you, you can think about it a second, is what did I do? Think about that for a second. Well, a lot of us that have been in the industry a long time know the standard joke when you call the helpline. One of the first things they said, have you rebooted your system? Have you turned it off and on? Well, that's exactly what I did with this Internet of Things smart plow. Is I turned everything off. I waited 30 seconds, turned it all back on, and all was happy. Should I have to do that? It's a fair question on that kind of thing. So the system testing problem. The question you got to answer, and as I said, a lot of managers, a lot of companies, they're just going to want the device only. But where do you stop testing? Testing only, the device will miss errors, will miss bugs. And people pointing, well, that's somebody else's problem to deal with that. Well, if you look at some of the pictures here, you got aircraft systems. If we crash an airplane for some reason, people don't want to know that, well, it wasn't my job. They want it to make sure that we don't crash the airplane. So the test plans, in my mind, should address these kinds of issues. If we're not going to test beyond a certain point, we need to disclose that, maybe provide that to the consumer, to the vendors that are using the device, to the agencies maybe using it, with the use cases that say, this is what we've done, this is what we haven't done on these things. And if you look at this picture, you should get the sense that there's probably a business opportunity here. I'm working with a company a little bit right at the moment. They work on the cloud side, this section in the middle there, and they connect to a variety of Internet of Things devices, both the hardware, but they also have the ability to model a lot of these things. Why? Because they want to be able to test this whole big picture of maybe where you've got the consumer side and the factory side and the home side of things, and everything's communicating back and forth. So there's starting to be tools out there from vendors to support testing this kind of picture. Now, should we all go off and test everything in this picture? Probably not. But again, you have to kind of disclose, this is what we've tested, this is what we haven't tested. And then a user or maybe a government agency can come along and go, oh, we're going to pay for the rest of that by having something like an IV&V organization. And way back in my career, I was part of an IV&V organization. And we tested what another developer produced, and we were hired by the government to do that testing. So the steps in IoT system testing. You want to start kind of down there at the bottom of proof of concept. This is in the agile world where you're maybe getting some developers doing some testing, and the product's really not there and the hardware's not really there, and you're checking a few things. But we are starting to think about the test architecture, where we're all going to test things at once and everywhere, maybe. Maybe put in a plan that says, hey, we are going to cover this. We're not going to cover that. Moving up from that as the product matures to the level 1 box, we maybe do some limited testing in an agile sense. Put it out to some users that are, maybe part of a market study or market survey. Maybe have to do a non-disclosure agreement with them, but we put it out and start using it as the system continues to evolve, both the hardware and software. Moving up in the maturity, we go to a box of first production runs. We have a viable product now. We can put it out there. We maybe sell it at a discount in the early things, but we start getting some information about, well, this is working, this needs to be improved as the product matures. And you move to box 3. Now we're starting to maybe produce hundreds or thousands or maybe even millions of these devices. A lot of companies are going to want to be that in the production runs. They're wanting to be the market disruptor. They want to be the next Google or the next Facebook in the IoT world. I think they're going to be out there. I don't know who they're going to be, but I think we're going to see those kinds of things. And then finally, up there in the maturity level 4, people will want to start having devices that work, that are solid, both the hardware and the software, where we can start, making some profits. To do this, the teams are going to have to collaborate and work in that agile DevSecOps sequence of continuous improvement of things. So verification and validation. These are system level IoT activities. It can be V&V, which is internal maybe to the development organization, or IV&V, which maybe somebody hires an outside contractor to go do verification and validation. I will say my opinion is that for a lot of IoT devices, particularly in the industrial side and I'll call it the government side, I think there'll be a lot of business opportunities for companies doing IV&V in theirs. So what are some of the specific techniques that are talked about in verification or both in validation? I don't have time to go through every one of these, but these are classic ones that are talked about in a lot of books. Also some standards out there. There is IEEE 1012, which is a standard on this. You have verification, static analysis, inspection reviews, formal verification, which is mathematical proofs and model checking, and then the classic checking of requirements test techniques that most of us are familiar with, which there are many of. In the both category, well, testing, analysis, demonstration, showing the thing works out in the field. We're all going to have regression testing. That's just the fact of life for all product lines. I'm a big believer in exploratory testing. If you don't know what that is, lots of books on that. Relates to error guessing. James Whitaker talked about attacks and tours. I really like those. Some of my other books have those things in them. Patterns in testing, levels of testing, starting at the unit, integrations, software level, system level are all different levels of testing. Model-based testing, I think, will be applicable to some IoT devices. And I've mentioned already several times the notion of automated testing. I think we'll do some manual testing, but automation will be the way to go. More on that coming up. And finally, on the validation side, well, what kind of use cases do we know? Alpha and beta testing, system testing, simulation and emulation, prototype testing, maybe with some users that we bring in prior to official release, model analysis, hardware, software testing, and quality techniques testing. All these things fit inside of the V&V, IV&V domain. And again, there's books and standards out there that address all these in detail. We will leave it at that. So skills for the V&V, IV&V tester. What things should you be looking at? Well, I advocate that even if you're a software tester, you need a little bit of understanding of the hardware and the hardware engineering and the testing and assessment that goes on of hardware. Places I used to work, we used to call them shake and bake testing. I've been in some hardware labs for things like loudspeakers that you would have in your home. They did that stuff there too. So I think software people should know, maybe not be experts in hardware testing, but you got to know something about it. Agile software engineering and testing. Hopefully this conference and other things, you know a little bit about being an agile software person. I've worked in agile projects for, probably 20 plus years when it first came out. Big believer that agile is the way to go. But less familiar to a lot of people is agile system testing and system engineering. These are all separate areas, whole books on that. And those are the kinds of skills to start going off and looking at. So with that, AI and data analytics and the deployment and operations of things. We want to be able to identify potential project management, planning, risks, and impacts in the planning cycle. All those ones above need that. Documentation and technical communication. I don't know anybody that really likes doing documentation, but having been involved in a few ugly situations, documentation is very useful when things go wrong. Working knowledge of programming and model engineering. If you're not familiar with models and use of models, you should get that skill because those things lead to test automation and analytic approaches and analysis. I'll mention now again, verification process and standards. People have a love-hate relationship with standards. I understand that. I've worked on standards off and on for years. It's easy to like them. It's easy to hate them. I mentioned IEEE 1012 here. There's others, whether you're in the FDA or ISO. You should maybe have those in your library. And have a little question there in the bottom. How many books, either electronic or hard copy, do you have in your library? I have behind me 2 big bookshelves, about 4 feet by 6 feet, filled with books. I look things up all the time. I have access to a lot of standards. I look things up there too. This is how one, I'll say, gets smart. It's by having a library of things on verification, validation techniques. You can't keep all of that up in your head all the time. But if you know how to look things up, people think you're really smart. So next big topic, constant security testing and assessment. Once upon a time in the embedded world, we didn't worry a whole lot about security because we weren't networked. So therefore, what was the problem? Internet of Things is taking embedded devices and many kinds of devices and putting them on the internet with a connection. All of a sudden, security becomes a big deal. This is kind of one of the agile DevOps infinite symbols here, where you see a whole bunch of security techniques that we'll look at here in a moment in a little bit of detail that go on. But I mentioned here at the bottom constant. It's you do it all the time, you do it all at once. In my book, you're never done with the security testing. I realize a lot of management people don't want to hear that, but if the device is being updated and modified and continues to evolve and change, the bad guys are going to be out there looking at you. And you do not want to be hacked. And so you have to be thinking about these techniques. You have to be doing them during initial development, but then as you go into the DevOps and particularly the ops cycle, somebody needs to keep thinking like the bad guys. And not every tester is going to do that, but the ones that do it, I think will be in a lot of demand. So I mentioned in the infinity symbol some of these names. The first one there, social engineering, thinking like the bad guys. When I first ran into that term, social engineering, I was like, well, that's kind of funny, but it's what the bad guys are out there doing. You know, we're all now probably well familiar with all the phishing phone calls we get and all the phishing emails we get. Hopefully, you know to not answer and to hit delete. But as a tester, I started learning how to do that stuff. First in the list there, pen testing, penetration testing. This is where the tester is going to attempt to break into the system, break the security of the system. If you can't, well, maybe you need to try harder. What we're ultimately trying to do with like pen testing is access secure information and see what kinds of things we can find out. I mentioned hacking baby cameras. Any of us that have had children regard that as kind of sensitive information. Really don't want pictures of my baby out on the internet. After that, access control and password cracking, PK crack. There's tools, a whole bunch of them out there that the bad guys will use to circumvent passwords. A lot of people have really lousy passwords. Most of us now have little checkers that say, hey, this is not a very strong password. On some things, we have two-factor authentication. Better, but still not 100% secure. So if we can crack in to a system when we're not supposed to be able to, the next thing you want to do in security testing is elevate access privileges. We want to try and get somewhere or do something that we're not supposed to be able to get to. There's a famous story of a large department store that got hacked with their point of sale systems, people's credit card numbers. The hackers went in through what I would term an IoT device. They went in through the HVAC, the heating, ventilation, and air conditioning system, had some software, was hooked to the internet. They went in through that and got into the point of sale system. That's elevating privileges. Bad day for that company. Denial of service attacks, I've mentioned. IoT devices have already been used, hijacked, a whole bunch of them to do a denial of service attack where we go after a website, maybe somebody like Facebook or Netflix or somebody like that, and flood them with requests and use IoT devices to do that. Again, don't do that, on your own. But when we were doing security testing of our device, that's something to look at. Security taint analysis, I'm not going to go in through a whole lot. The book has some details on that. It's mentioned here just because I want to be complete on that. Tampering attack, where we try and break into the hardware to gain access. I mentioned the department store. They were definitely getting tampered with. Can we modify and do things to the CM and SCM, configuration management and SCM system? Does the system notice that something is going on, inform other stakeholders of things, and send me an email that says somebody's messing with your bank account, as an example. So we got to know these things about particularly operations side. So as I've already said, for me, security testing doesn't stop when we're already selling, deploying, but we continue it. If you don't know the OWASP site, you can do a search on that. OWASP and ZAP, some good stuff on that. Again, no presentation can cover everything, but point you in some directions. Malware and security, attacking of off-the-shelf malware. Places I worked, we were sensitive enough. We didn't like using, I'll say, unproven, uncontrolled third-party software. We had a process to make sure there wasn't malware sitting inside the software on that. And the final one there, spoofing attacks. Most of us are familiar where we're spoofing web names, IP addresses, protocols, GPS has been spoofed. A lot of IoT devices are going to have GPS and users and identities. I'll, at the very bottom there, plug the Breaking the Software books, Test Attacks and Security is the Breaking the Software by Whitaker, James Whitaker, Thompson, and my book was separate from theirs, but those books, good stuff on security testing if you want more in that area. Security testing your future, your skills. Again, you've heard this already, build up your software engineering skills. I was a tester, but I was a software engineer first. I became a systems engineer and knew just enough about hardware where I could talk to the hardware people about the devices and the hardware. Partners and suppliers. Places I worked, we had very close relationship with our vendors, including going to them and assessing what they were doing for their testing, particularly from a security standpoint. Learn about test governance, standards, certifications, and guidance. Yes, I know people hate standards, but you go to a lot of places, particularly in Europe and other countries, they're going to expect it. They're going to say, are you XYZ standard compliant? You need to be able to say yes, no, or go find out quickly. And then finally, testing quality characteristics, particularly security. One standard that I'm currently supporting is IEEE 982.1. It talks about performance, interoperability, reliability, dependability, a little bit on security, maintainability. That's standards currently under revision, so some of those things may change, but that's the kind of stuff you need to know is out there for your, I'll call it careers and your products. So everywhere. So this is kind of a flashback to a version of the picture earlier. Everything, everywhere, all at once. We have the house there on the kind of bottom left side where a lot of our devices are going to be maybe in the house. Could be a factory, could be something larger scale, but here showed as a house. The development people need to think, well, how is that smart solar panel going to be used in the house? What kinds of things might be in the house? And there is no such thing as a standard configuration for a house. There are vendors, like Apple's really good at it, where if you get all the Apple things, they'll all work together. But how many of us don't have a mixture of things in our house? So the development people need to think the testing and V&V as we go into the house. I then advocate kind of there in the middle, the data analytics, the DA, and the AI. We're all hearing in the news these days about artificial intelligence and ChatGPT, and I've played with that stuff, and it's interesting, and I've programmed some neural nets, and it's a lot of fun. It's coming to, I'll call it fruition now, and testers in the IoT world are going to have to know this stuff and be familiar with it. It's the future, and maybe the future is already here on a lot of these things, on the data analytics and the AI. And that's going to feed into the stakeholders and the company use in the cloud. It's happening already. So pretty busy slide here, but the dev, test, SecOps improvements must start including AI and data analytics. That's just the way it's going to be, either as users or having team members that understand data analytics and understand AI. The massive amount of data that IoT devices will generate will necessitate data analytics. I don't know how a human being can handle a terabyte worth of data. In places that I've been into, they're talking multiple terabytes in a single test, and then running thousands of tests. If you're not doing data analytics and maybe using AI, I don't know how you're going to manage that. There's just too much data. The data is going to flow from the real world at the home and the edge, into the cloud. Data analytics is going to happen on that. Word of advice: the data analytics people send, and the interested parties in companies tend to be on the sales and maybe a little bit the operations and the management side. They go, yeah, how can we do something, to increase our sales? And the management people tell the operations people, let's sell more. Well, I want to advocate to the testers, probably the development staff too, but certainly testers, you need to be in there getting access to that data too. And that's going to require some knowledge of statistical tools and concepts out there. And if you're not looking at AI and data analytics to improve things, it's a huge mistake, a big mistake. And once upon a time, I was a mathematician. I found in recent years I had to go back to my mathematics, back to my statistics as I got into things like AI and data analytics, so I could at least talk to the experts on these things. So the skills associated with this testing and data analytics. Well, you've heard it before, repeated third time: systems engineering, software engineering, security engineering. Absolutely. Knowing the software test architectures, the environments, the house, the edge, off into the cloud. That's a whole environment that you're going to have to understand and either say, we test this and we don't test that. We're going to test the cloud. We're not going to test the cloud. Be honest about that. Knowledge and familiarity with test frameworks and tool sets. I mentioned the cloud-based tool, unit testing tools, AI testing tools, and continuous integration. Those things are all going to be out there. And you as a tester or somebody supporting development, you're going to have to know this stuff. You're going to have to know statistics, AI and data analytics. I know a lot of people are afraid of mathematics, but parts of it aren't all that hard if you just spend some time or find the right person to buy a beer and have them help you with some of the things. Understanding the AI processing for tools and data analytics to generate test cases. We're seeing tools now in that area. And I think the days of a lot of manual testers going to be circumvented by the AI systems out there. Does that mean your jobs are totally going away? No, they're just going to change. And people that can run the AI, run really good exploratory testing with the AI, maybe watching, those people are going to be in demand. The human smarts down there at the bottom underlined, the test automation driven by AI and data analytics, but it's still going to be smart people driving these things. And I talked with a couple of the experts in the software test world that are working in AI. They agree with that. That's our belief what the future is going to look like for you all. So a little bit of summary here. Some of these things are my prediction, but it's based upon having gone through several large explosions like the World Wide Web. I think IoT is going to unfold and evolve. Some of the things I'm telling you probably be a little bit different, but I think some of these will be borne out. I've advocated in this presentation and in my book, system testing and security testing beyond just the device itself, everywhere, kind of all at once. The things you should focus on, V&V and IV&V at the system level at some point. Security testing and assessment, everything, everywhere, all the time. And I mentioned just briefly AI and data analytics. If you're unfamiliar with those things, it's time to start getting familiar with that stuff. I think there's a world of possibility, particularly in the AI side of things. Oh, there we go. I want to say thank you to everybody to listening and to InflectraCON for allowing me to do this session. I'll point you again at the book out there on Amazon and all the popular sites, IoT system testing. And just a reminder, IoT is in my snowplow. IoT is up there in the buildings when I was out hiking. And IoT is in my solar panels. It's everywhere. It's going to be in everything and all at once. And with that, I'll say thank you. Again, this is John Hagar.
Thanks for joining us for this virtual bonus session. We hope you enjoyed it. Learn more about InflectraCON, our live, in-person conference from April 19th through the 21st, 2023 in Washington, D.C. by visiting InflectraCON.com. Stay tuned for more great content, news, and events from Inflectra. Learn more at inflectra.com/events. inflectracon.com/company.